Hello and welcome to the SQL Mastery Course. My name is Bhaskar Dev Goyal. I am a data scientist with a US based organization and I have been working in the field of AI and data science for more than 5 years now. In this course, I will be your mentor and guide. Together, we will learn SQL step by step, starting from the absolute basics all the way to an advanced level where you will feel confident in saying that I can do anything in SQL. Now, a quick word about where you are learning this from. I am a mentor at Let's Decode AI, a platform that focuses on practical hands on learning. Our philosophy is simple: learning AI and data science should never be about theory, it should be about solving the real world problems. And with that, let's begin our very first session. Here is a quick roadmap of what you will achieve in this course. In level 1, we will focus on SQL foundations, the basics, writing queries, and getting your setup ready. In level 2, we will move to intermediate SQL joins, aggregations, and subqueries, which will allow you to get a better hands on understanding of how to create and what the SQL query structure looks like. In level 3, we will go deeper into the advanced SQL, where we'll learn about the concepts of window functions, optimization of the databases, and the database design. We'll try and understand how a database is designed, what are the different ways by which we can try and optimize the performance of a database, and finally, in level 4, we'll apply the SQL in a professional world. We'll work with the ETL pipelines and we'll try and understand what ETL stands for in the level 4 section. But we will also handle the JSON data, even integrate SQL with Python for AI workflows. Finally, we will wrap everything into a capstone project where you'll work with the real data set and showcase your skills. So this is not just a theory session. By end of this journey, you will have the practical experience to use SQL in real projects. Let us get started with day 1, lecture 1, introduction to databases and SQL. Before we jump into databases, let's step back and talk about data. Okay, this is one of the most crucial, one of the most basic, but still one of the most misunderstood terms in the world of AI, data science, and overall AI engineering. Data is everywhere. Okay, this lecture that you are listening to right now, my voice, my video, the text that is coming up in front of you on the screen, this presentation, the images, the browsers, the websites that you browse using those browsers, people around you, everything is data. To put it simple, data is information, and this information can be classified into two different categories: structured data and unstructured data. Structured data is what SQL is built for. As the name suggests, structured data has a certain structure to it. Think about an Excel sheet which has rows and columns, neat, organized, and easy to understand. That is what a structured data means. A data that can be organized in form of tables, in form of rows, in form of columns, and a meaningful information, meaningful knowledge can be extracted from those tables is called as structured data. For example, customer names, product prices, exam scores, student attendance, all of these different forms of information can be fit perfectly into a structured data. On the other hand, unstructured data does not fit into the conventional table. It could be maybe a YouTube video, or a post on Instagram, a paragraph or a text from a blog post which is very big, or maybe some tweets on Twitter, right? My audio, my video feed, all of these different form of data which cannot be arranged in form of a table is called as unstructured data. As a data scientist, we work with both of these data types, and structured data is a type of data which is most often found when you are getting started with the data science world, or you are actually working on a machine learning problem. Whereas the deep learning phase, the generative AI phase, is something which is built upon to try and understand and use the unstructured data. So as of now, we will be diving ourselves into the world of structured data, where we'll understand how the structured data is created, how the structured data is stored, and how the structured data is used to extract useful insights from it. So once we have the data, like the tables, what do we do with that data? Where do we store it? Where do we put it? One initial thought which could come in your mind is, we can store this data in form of Excel sheets. We can store it in form of Google Sheets, right? Because that is the primary way by which we have been visualizing, we have been storing, and we have been accessing tables on our laptops. And you're not wrong actually. Microsoft Excel, Google Sheets are a form of database. Okay, but the problem is, if you have, let's say, hundreds or thousands of rows, storing them or having them in your Excel sheets or Google Sheets is fine. But if you are dealing with millions of records, let's say millions and millions of bank transactions, billions of social media posts, you need something powerful, because at that point of time, Excel and Google Sheet are going to hit their limit. And also the speed at which you will be able to access that information is not going to be good, which is the reason why we dive into the world of databases. A database can be thought of as an organized collection of data which allows us to store, manage, and retrieve the information in a very efficient form. Now, databases are everywhere. The e-commerce applications that you use, maybe Amazon, Flipkart, or your online banking system, your email provider, even the Netflix and Amazon Prime recommendations, all of these are run on databases. You can think of database as the memory, the brain, not the brain, but the memory, the core, the backbone of every web, mobile, and other application that has information in it. Without databases, you won't be able to log in. You won't be able to fetch your records. Without databases, the social media won't exist in the first place. So, understanding the database and knowing how to handle a database is one of the most crucial concepts when you are starting your journey with AI and data science. One of the most common types of databases is the relational database. Here, the data is stored in form of tables with rows and columns. Now, there are a couple of terms which you will listen a lot from me, which is record and attribute. Now, a row in a table is called as a record in a database terminology, which can be thought of as those horizontal lines in a table, which are used to identify a unique person's, or let's say entities, information. Okay, let's take an example. Say you are creating a database for a school application. Okay, now that database has a table which has information of student attendance. Now each row of that table is going to correspond to every individual student, and the columns, which in databases term we call as attribute, is something which will store the different features, maybe the name of the student, the age of the student, the standard of the student, the date on which the student was present or absent, right? So these are the two main components of a table: row and column. Relational databases are very powerful because we can link multiple tables together. Okay, this is one more reason why we have a preference of using relational databases instead of a Excel sheet or a Google sheet, is because in a Google sheet you will be able to access or view one table at a time, right? One sheet at a time. But let's say for a complex system like a school database or school management system, you will have a lot of tables. One table could be for a specific class, let's say standard 1, standard 2, standard 3, standard 4, right? Another table could be the personal information of each and every student. There could be another table which is the marks scored by the students in a certain exam format, right? All of the information is scattered and present in form of different individual tables. Linking those tables together and extracting one information from table 1 and then its respective information from table 2 can become a little complex. For reference, let's say you have a class 1 table which has the unique student personal information. Okay, now you are looking at a student and you saw a student named ABC. Now that ABC student is someone you're interested in. You want to see what is the performance of the student in the class, but that performance information will not be present in the table that you are viewing at the moment. It is present in some separate table called as class marks, right? Now what you will have to do is you will have to copy the name or the roll number of that student, then go to that another table called as class marks, search for the name or the roll number of that student, and then find what are the marks, right? And I assume you can already imagine how hectic it will become if we are dealing with a large volume of data and we are dealing with a large organization like maybe Amazon. That is the reason why the concept of relational databases was introduced, because these databases allow us to create a connection between multiple tables based on different attributes in different tables. For example, I can link the class information table, which has individual respective student information, with the marks table by the means of an attribute called as roll number, right? Because roll number is something which will be present in both the tables. I can use that to link it. Now next time when I want to fetch the roll numbers or the name or the father's name of a student, I can do that from a single place instead of scrolling and dodging and jumping from one sheet to another. So some of the most widely used relational databases are MySQL, PostgreSQL, Oracle, and SQL Server. For the scope of this tutorial, we are going to work on MySQL and PostgreSQL, because once you have information for these two, you will be very easily able to handle Oracle and SQL Server as well. There's nothing unique or nothing different in these. It's same. Okay. Now, the question is, what is SQL? Okay. Once we have a database, like the previous example of a school management system, we have a database. We connected the tables in that database with one another using the roll number. Now, let's say if you want to extract the name of a student, let's say, okay, let me write it here. You have your table 1, you have your table 2. Okay, I think this pen is not working properly. Let me clean this. I have another tool with me, this one. Okay, so choose pen. Yeah, so we have a much better table 1, we have a table 2. So we have these two tables, and let's say the attribute that I'm using to link these two tables together is called as roll number, right? But the question is, all of this information is present in something called as a database. How a database looks like, we will see it in a little while, but let's assume it's a bubble. Okay, a bubble has two entities, table 1 and table 2, which are linked to one another by a field or an attribute called as roll number. Now the question is, how are you going to extract information from it? So for that, we have something called as SQL, or it has a full form which is structured query language. Okay, structured as in the structured data, and then query is a term which we will use to query the data. We want to access the data, we want to manage the data, right? And then language, it's a type of language, just like Python or other programming languages. It is a language used to handle the structured data or structured databases. So SQL allows us to create tables, insert new data, update existing records, and even retrieve the information that we want. So for example, if we want the let's say father's name of a student who scored less than 30%, right? Maybe the student is failed, and you need to complain to his or her parents that your son is not working, your son is not learning properly. You need to look into it, right? So you need the father name. So there is a link between the two tables, one table having the marks, another table having the personal information of a student, both linked by the roll number, and this is the condition that we have, right? We want to extract the father's name based on the marks that the student has scored. In order to do this, we will use SQL. So it is used to communicate with the relational databases in a structured format, and it allows us with a much more reasonable and faster form of communication. This process is called as CRUD. So this is called as CRUD operation. CRUD is nothing but a short form for create, read, update, and delete. Okay, so you can create an entry, create data, you can add data, you can read some existing information like we wanted to do here, you can update some information. Let's say you want to change the marks. There was a re-evaluation that took place, and now it was established that the student did not actually get 30%, but he or she was a good student and got 80%. It was just a typo, right? Maybe you want to update it, so you can do that using these operations as well. Or Let's say there is a wrong entry or some wrong data and you just want to delete it. You can delete that data from a database using the CRUD operations too. In data science, SQL is not limited to these 4 operations. It is much more. We use it to extract large data sets for analysis, cleaning, transformation, and we also prepare the data for some machine learning tasks. Now this is something which you will get aware of once we reach to level 4, but as of now let's keep the scope of this conversation till the CRUD operations. So you can think of SQL as a universal language for data. If you want to work with data, SQL is something which is non-negotiable. If you want to become a data scientist, if you want to become an AI scientist, if you want to become a machine learning scientist, or even if you want to become a machine learning engineer or a software development engineer, SQL is a must. Now, in this course, we will work with 2 of the most popular relational databases out there, which is MySQL and PostgreSQL. MySQL is a very simple, reliable, and one of the most used database systems present out there. So almost 70 to 75% of all the web applications that you access are based on MySQL. Okay. On the other hand, PostgreSQL is a little bit more advanced. It supports more complex queries, analytical functions, and even some advanced integrations and extensions. For example, nowadays there is a very big demand of something called as LLM chatbots. Okay. Now these chatbots have something called as a knowledge base or a KB. It's nothing but a database where all the information which is present as in memory of the LLM is stored. Now this PostgreSQL has an extension called as PG vector, which can be used to create this knowledge base and store this knowledge base. And also it has another extension called as PostGIS, which is an extension used when you are working with geospatial data. So geospatial data is nothing but map data. If you are dealing with geo coordinates, map information, road networks and all, then PostgreSQL is your go-to database instead of MySQL. And it even supports some semi-structured data like JSON. So for a lot of use cases, Postgres is the first choice for people, which is the reason why in this course we thought of adding both MySQL and PostgreSQL for your journey from beginner to advanced, because even though there is a massive overlap between the functioning of these 2 databases, there is still some extra use that you may have from one as compared to another. Personally speaking, in my own career, I have used MySQL when I was working on a few web-based projects as a freelancer in my college days. So I had built a few WordPress as well as normal HTML JavaScript based websites. So MySQL was one of the most used databases at that time. It's even used now. Postgres is something which I have used and I have been using in my projects which have AI agents involved, which have smart chatbots, AI chatbots involved. So in that case, I prefer to use PostgreSQL, or there's another name to it which is PGDB. Okay, PostgresDB. So this is something which you will hear a lot. So just think of these as interchangeable terms. Now, since we have a basic understanding of what these both softwares are, we'll start by installing MySQL and PostgreSQL. So to follow along in this course, you will need both MySQL and PostgreSQL installed on your personal computers. So if in case maybe you are watching this lecture from your mobile devices or tablets, I will suggest that you stop the video, just open up your laptops. It does not matter if it is a Linux, Windows, or maybe a Macintosh, but it's all fine. These softwares are supported on all the three major operating systems that are around out there. So just open your laptops and follow along with me. Okay. Now for the installation purposes, we will be using the official website of both MySQL and PostgreSQL, and will follow their installation wizard. Just in order to provide you with a much better clarity, I have added links for a few installation resources, online resources for the three different operating systems: Windows, Mac, and Ubuntu. Even though the process is fairly simple and easy, but still, if in case someone feels like they want to use some external resource, they can. Okay, now let's try and see how to install MySQL. So in order to install MySQL, you will just simply type MySQL download for Windows. Okay, I'll write this, I'll click on enter, and we have this option of MySQL installer. Just click on this, and from here it will automatically detect your operating system, and then you can click on download the installer. It's your wish if you want to download the setup first and then install the MySQL inside the setup, or if you have enough bandwidth as of now, you can directly download this 350 MBs of file. We are going to choose the latest version of it, and if in case you are looking for a specific version, you can click on archives, and it will take you to all the previous versions of MySQL that are present. Okay, so these are all the different versions available, but we will be using the latest one, which is 8.0.43. So just click on this download button. Let's say I'm clicking this one, then it will show you this window, and you do not need to log in or sign up. It's just formality. We will click on no thanks, just start my download. Once I click that, it will start downloading it on my system. Okay, so I have already downloaded it earlier, so we'll open that. Along with this, we also want PostgreSQL, so you can just write PostgreSQL download Windows, and it will take you to this PostgreSQL Windows installers. Just click on it, and let's wait for the website. So these are all different versions that are available. We want the latest version, which is Postgres 17. It was launched in 2022, and here we have an option of downloading the installer. Click on it. It will take you to a website called as EBD, and here we have an option of Linux, Mac, and Windows. Mine is Windows, so I'll click on this, and the moment you will click it, it will show you this page, but just ignore this one. Your download will automatically start up here. Once the download is complete, we will have something to work with. So let's wait till it completes, and then we'll install both of them one by one. So I'll be pausing the video and come back once the download is done. Okay, so I am back, and the download is complete. As you can see, we have both the softwares downloaded, and so let's click on the download button. Okay, so I'll click on this MySQL installer, and it will pop up a window for me. As you can see, it is configuring. It asks for me a permission, and the installation has started. Okay, so this is how it is going to look like. The shark is the logo, and right now it is showing me something like this because I already have MySQL installed on my system. But if in case you do not have it, you can just click on next. There's nothing very complex in it, but if you still feel like you're not able to follow and you need some guide, I have added these helper links which you can follow to try and see how to install MySQL on your system. Okay, so once you have done it, installed it, you will have something called as, let's say, it will open a software called as MySQL Workbench, which looks something like this. Okay, I have already set it up, but um, if you want a full on tutorial for how to install MySQL from scratch and how to install your PostgreSQL from scratch, do let me know. Please add it as a comment, and I'll make sure to wipe these databases from my laptop and then install them from scratch for you guys, so that all the doubts that you have are cleared. Okay, same way, the PostgreSQL is now downloaded. If I click on it, it will open up the window for PostgreSQL soon. And just like MySQL server, PostgreSQL is also installed on my laptop. So if I, okay, so we got an option. It will be popping up soon. Yep, it has. I'm not sure if you're able to see it because it's on the another screen. Okay, so this is how the installer would look like, and you just need to click on next, and it will start the installation for you. Okay, now the moment you will click on next, the setup will be ready and you can install PostgreSQL on your computer. I'll abort it because I already have it installed on my laptop. There is one more software which I would highly recommend you all to download. It is called as dbeaver. Now dbeaver is a open source universal database tool which allows us to connect with all of these different types of databases. So if I open the list of all the different databases that it supports, the list is very long, right? As you can see, it supports everything from Athena, Apache to CrateDB, and it also have an option of, let's see, MariaDB, MySQLDB, your Neo4j. Neo4j is a graph database. We'll discuss about it in our advanced lectures, not in the SQL or NoSQL databases, but in the advanced lectures. And then it supports Oracle DB, it supports PostgreSQL, it also supports your NoSQL databases like Mongo. There will be an option of Mongo here. Let me search. Yep, it handles MongoDB as well. So there are a lot of different databases that it handles. In order to install it, just click on download, and here you have an option of downloading it from the official website. For Windows, in my case, it has an option to install it from the Microsoft Store. If you have Windows, I would highly recommend you doing that because it won't have a lot of setup involved. It's easy. Just click on Microsoft Store, install it, and you are good to go. And just to show you the UI, let me see. Okay, let's install it along with you. I think I removed that earlier. So this is how it will look like. Click on download and it will start downloading dbeaver on your local system. So the installer is installed now. I can click on it. It will start downloading the official dbeaver repository. As you can see, it's pretty quick. Okay, as you can see, it's opening up. Yep, and this is how the dbeaver's UI look like. In this case here on the top left hand side, we have an option of new database connection, which you can access by Control Shift N as well. So if I do Control Shift N, it will open this option to connect to a database. Now it has SQL databases, a lot of those. It also supports NoSQL database like Cassandra, TimeStream, Mongo, Redis, and Couchbase. I've never worked with Couchbase, but it's fine. Then it also has basic file system support like CSV, DBF, and even Microsoft Access. And it is also having an option of time series data. So in the advanced sections of the whole AI and machine learning journey with your Let's Decode AI, you will have a specialized course for deep learning with a specialization in time series data, which is also called as digital signal processing, and this is something which will be used there. It also supports big data like Hadoop and Apache. Then we have full text search like Elasticsearch. So it is again one of the popular famous databases used for LLMs or LLM based chatbots. And then we also have an option of graph DBs like OrientDB and Neo4j. Now since we are using a free version of it, the availability of the database is a little limited, but for us the use case, it's more than enough. Okay, so with this we have successfully installed MySQL, PostgreSQL, and dbeaver on our laptops. If in case you feel like you still have some confusion or you want some extra help, do let us know, and I'll try my best to connect with you guys and maybe create a dedicated recorded session for installation guide on MySQL and PostgreSQL. In the next class, we will move beyond this setup and will start writing real SQL queries to explore and filter the data. So congratulations guys, you have taken your very first step into the world of SQL, and finally after the completion of this course, hopefully you will have enough knowledge about SQL and relational databases that you will be able to move forward in your journey in data science and AI. Till the next lecture, thank you so much. Good night, good evening, thank you.